Jain friends, myself Sachin Jain, Assistant Professor, Department of Computer Science and Engineering, and the series of compiler design lectures. In the first lecture today, we will discuss compiler design phases and passes. So in today's lecture, we will discuss these topics: what is compiler, compiler versus interpreter, preprocessor, compiler, assemblers and linkers, phases of the compiler, analysis synthesis model of the compilation, passes of the compiler, and compiler construction tools. So what is compiler? Compiler is a translator that accepts the source program written in the probably in high level language such as C, C++ and convert it into the objects program or a low level language such as assembly language. So basically compiler is a translator which converts high level language program into the low level language program, or you can say assembly language program. There are various activities done by the compiler during this process. If there is some syntax error identified, then appropriate error message should be displayed along with the line number by the compiler. Second, an optional list file can be generated by the compiler. And third one, compiler replaces each executable statements in high level language into one or more machine level language instruction, and it converts high level language into the assembly language or object program if object program or if the program is syntactically correct. So basically these are the four activities done by the compiler to translate a high level language program into the machine level language program. Now let's see the difference between the compiler and interpreter. Compiler takes the entire program as an input, but interpreter takes single instruction as an input. So it will convert the whole program at once and it will read line by line or based on the instruction. Compiler is faster, interpreter is slower because it reads the programs line by line. Here intermediate code is generated. Here no intermediate code is generated in case of interpreter. Program require more memory due to intermediate code object because intermediate code is generated here, so it takes more memory, but it requires less memory as there is no intermediate code. Here in case of compiler, program not need compile every time, but in case of interpreter, every time higher level language program is converted into the lower level program, so it is also the burden on interpreter. Error are displayed after entire program is checked. Here error message get displayed after reading single line or every instruction when it is interpreted. Debugging is comparatively high in case of compiler, but debugging is easy in case of interpreter. So example of compiler is C, C++. In both the languages we use the compiler as a translator, and in case of Python or Ruby or many other languages we use interpreter as a translator. There exists some hybrid compiler as well, which is the combination of interpreter plus compiler. So the compilation and interpretation may be combined to implement a programming language, and the compiler may produce intermediate level code which is then interpreted rather than compiled to the machine code. So when we combine compiler and interpreter both, just to convert source program into the machine level language program, then that type of compiler is called as a hybrid compiler. So in case of Java, we use hybrid compiler, that is the combination of both compiler and interpreter. So you can see that there is a source program which is compiled by the intermediate program, and then this intermediate program is further interpreted by the interpreter, and further output is produced in case of hybrid compiler. Now let's see what is preprocessor, compilers, assemblers and linkers. So generally compiler doesn't take directly as a source program. First it goes through the preprocessor. So preprocessor makes a program that can be read by the compiler. So some preprocessing is done by the help of preprocessor, and then this, after preprocessing, the source program is given as an input to the compiler. Compiler, if required, then it may use the assembler and it may use the linker to link the essential libraries and relocatable objects files. Then further source program get converted into the machine code. So this is the process how preprocessor, compiler, assembler and linker works. So preprocessor makes program readable by the compiler. Compiler may require assembler. It may require linker just to link the necessary libraries and other files, just to convert source program into the machine code. Now let's see the phases of the compiler. Basically there are 6 phases that are grouped into 2 main parts, that is called as a analysis part and synthesis part. We will discuss analysis and synthesis in the later section, but let's see the different 6 phases of the compiler. First phase is lexical analysis, second phase is syntax analysis, third phase is semantic analysis, fourth phase is intermediate code, fifth phase is code optimization, sixth phase is code generation. So the source program get converted into the target program, or you can say low level language program, by going through these 6 phases. All 6 phases are connected with symbol table in the left side and error handler in the right hand side. And when we group these 6 phases in a group of 3 and 3, then first 3 phases is called as a analysis part, and last 3 phases are called as a synthesis part. And if there are some error occur in all the phases, then there is a error handler mechanism, and all the necessary data that are required to be accessed by the different phases are stored in the symbol table. So symbol table maintains the data structure that is required by the different phases of the compiler, and you can see that there is a connection between all the phases and the symbol table, and similarly there is a connection between error handler and all the phases of the compiler. So what is the job of this first phase? Lexical analysis just convert the source program into the tokens. So output will be, it will read the source program and it will convert into the tokens. Syntax analysis will read these tokens and it will convert into the parse tree. Semantic analysis will make this parse tree more annotated. So the syntax tree will be produced by the third phase. Some intermediate code will be produced on the basis of the syntax tree by the help of intermediate code generator. So intermediate code generation will produce the intermediate code. Then this code further can be optimized with the help of code optimization. The optimized code will be the output of this phase, optimized code, and further code generator will produce, after reading this optimized code, to the target program. So in this way, these 6 phases works, and each phase have desired outcome. First phase gives tokens, second phase gives parse tree, syntax tree is produced by semantic analysis. Intermediate codes are generated by the intermediate code generation, code optimization produce the optimized code, and further code generator produce the target code. So let's see the example. There is an instruction written as a position equal to initial plus rate into 16. So there is an instruction that is passes through the compiler. So first phase will convert this instruction into the different set of tokens. So identifier will be grouped into the another one set, operator will be grouped into the another set, and constant will be grouped into the another set. So set of tokens is produced by the lexical analysis, and the entry of corresponding symbols will be done inside the symbol table. Now syntax tree will produce the syntax parse tree and parse tree based on these tokens. So ID1 will be here, ID2 will be here, ID3 will be here, 60 will be here based on this instruction. So syntax tree will produce the parse tree. Semantic analyzer will produce the parse tree, but it is more annotated parse tree. There will be more data structure in this tree. So there's the only difference between this parse tree and this syntax tree. And this intermediate code will produce some temporary codes, and these temporary codes further optimized to the code optimizer, and final code, that is the assembly program, or you can say target program, in any phase of the compiler. Then error handler will report that error, and all the entries corresponding to the data that is required by the different phases will be entered in this symbol table. So this is the working of different pages of the compiler. Now let's see what is analysis and synthesis model of the compilation. As I told you that different phases of the compiler are grouped into 2 parts. First 3 parts is called as the analysis part, last 3 parts are called as a synthesis part. So there are 2 parts, and these 2 parts combinedly called as the analysis synthesis model of the compilation. So analysis part determines the operation that are implied by the source program, which are recorded in a tree structure, is called as the analysis part. A synthesis part takes that tree structure and translate the operation into the target program. These 2 parts, analysis and synthesis, also called as a front end and back end of the compiler. So we can say that analysis is the machine independent front end of the compiler, or synthesis part as a machine dependent back end part of the compiler. So analysis model says that the different phases of the compiler are grouped into the two part, analysis and synthesis. Analysis is called as a front end and synthesis is called as a back end. This one is machine dependent and this one is machine independent and this one is machine dependent. So we can see that first 3 parts are grouped into the analysis and last 3 parts are grouped into the synthesis part. Now, next topic is passes of the compiler. What is passes of the compiler? A collection of phases that may be repeated only once is called as a single pass or a If it is repeated multi times, then it is called as a multi-pass. Single pass usually require everything to be defined before being used in the source program, whereas multi-pass compiler may have to keep entire program representation in the memory. So let's see with the example. One pass compiler. When we group all the phases of the compiler, all 6 phases of the compiler into these one pass, means all 6 phases are grouped into a single pass, then that type of compiler is called as a one pass compiler. So we can see all 6 phases as we have discussed earlier: 3, 4, 5, 6, all 6. When we will break these phases into several other groups, like first 3 groups as a pass 1, then pass 2, last 3 groups, last 3 phases. So this is called as a 2 pass compiler. And further we can divide multi-passes, like first 4 phases in a as a pass 1, 5th phase as a pass 2, 6th phase as a pass 3, and then these passes are connected together just to convert source file into the object file. Then this can be 3 pass compiler, or we can say that multi-pass compiler. So in this way, passes of the compiler works. Some compilers may be one pass compiler, some compilers may be 2 pass compiler, some compiler may be multi-pass compiler. Now let's see compiler construction tools. So there may be some tools available just to cut short the work of different phases of the compiler, or we can say that the individual phases of the compiler can work independently by these tools. Like parser generator is a tool that automatically produces the syntax analyzer from the grammatical description of the programming language. So parser generator will work like a syntax analyzer. That is the second phase of the compiler. Scanner generator. Scanner generator act as a lexical analyzer that produce lexical analyzer from a regular expression description of the tokens of a language. So it act as a lexical analyzer. Syntax directed translation engine. So this is another tool that produce the collection of routines for walking a parse tree and generate the intermediate code. So this is working as a 2 phase of the compiler. It is producing the parse tree as well. It is producing the intermediate code. So 2 phases are combined using this tool. Code generator. Code generator generators that produce the code generation for a compilation of rules translating each operation of the intermediate language into the machine level language or a target machine for a target machine. So code generation phase of the compiler can be replaced using this tool. Data flow analysis engine. So this is exactly not the phase of the compiler, but it facilitates the gathering of the information about how values are transmitted from one part of the program to each other part of the program. So flow of data, how goes from one phase to another phase, or how data goes from one variable to another variable. This type of analysis can be done with the help of this data flow analysis engine. Compiler construction toolkit. There is a toolkit that provides the various phases work, so known as a compiler construction toolkit, that provides an integrated set of routines for the constructing various phases of the compiler. So compiler construction toolkit gives the many tools that can be used as different phases of the compiler. So that's all about the basics of the compilation. So in today's lecture, we discuss the many topics like what is compiler and interpreter, preprocessor, compiler, assembler, linker, phases of the compiler, analysis synthesis model of the compilation, passes of the compiler construction tool. So that's all from my side. Thank you.